guys, I would like to give some suggestions and help for the station work for Chapter 1 and Chapter 2. I believe I called it Jigsaw in the Google Classroom. So this activity should take 40 minutes. I would like you to take 8 minutes per question, and then I will give you a 2-minute commentary on each question, focusing on the rubric that was supplied by the AP. I'll give you highlighted points that you don't want to miss and suggestions along the way. So once you're done with question A, then go to question B. Again, hear the rubric and so forth. So here's what we're going to do. I would like you to push pause, and then when you're done, then I'll ask you to push play for the 2-minute commentary on question A. Go ahead and do question A. Push pause. So obviously you read the question and tried it, and oh, by the way, push pause or start. Part A was straightforward. The rubric did give you credit for the approximation of 2.5%, or if you used your calculator or table, you would get approximately 0.02275. They're not strict on writing approximately, but just to let you know, the answer is approximately that. But both were full credit, so whether you use the table or the approximation was fine. Okay, so obviously you saw question B was the hard one. I have given this question before on test, and I always gave it some hints, and my hint to you would be use z-scores. You don't have any data, so you're really stuck. Just, first of all, draw a picture. If you don't even know where to start, draw a normal curve. It says you have to be 1.5 interquartile ranges away. Well, an interquartile range means Q3 minus Q1. I have to find Q3 minus Q1. So Q3 minus Q1. Well, Q1 is the 25th percentile, which is right here. And then the 75th percentile is Q3. Well, I only have z-score. If I know a percentile, I can find a z-score. So go to your table, look for 0.25, go to the opposite, and find your z-score. How many standard deviations is away from the mean when you are in the 25th percentile? You can also, some people use their calculator because you sort of figured it out by now because the table's driving, if the table's too small, because it's too small for me. Some of you went to your book already and may have seen this. But you can certainly go to inverse norm and type in 25% and find the z-score. I recommend you use the table for 1 or 2 days, but if anyone has already jumped ahead, feel free to use your device. All right, the other z-score would be the 75th percentile, which is positive 0.6745. If you have it to 3 decimals, that's fine. Interquartile range, Q3 minus Q1. We got our interquartile range of, of 1.345, and times 1.5, you're around 2.02 units to the left of quartile 1. So we need to go 2.2 units beyond this. So our answer is this region, right? How do you get there? We're going to go 2.02 units beyond this, which is going to take me to this number. And now if that's how many z-scores, how many standard deviations I'm now to the left of the mean, how do we figure out that area under a normal curve? You just look this number up in your z-table. Or you can go to your device if some of you figured out how to do that. And I will do that right now. So here, we're going to go left side, and you would type in negative 2.695. You do not need to know how to do the calculator approach now. Later on, you definitely will. But those of you, I'm answering it now because some of you are intrigued. So there you go. It looks like your answer is 0.35%. We do not need to write it as percentages. We're absolutely okay with decimals. Okay, that's it for question number A. B, go to B right now. It's a front and a back, and push pause. Okay, so you really want to get full credit for A, because I thought B and C were the harder 2 rubrics to hit to get full credit. So A, you have to hit center, shape, spread, and stay in context. So center, shape, spread, stay in context. So here we go. For the 1 cup serving size, the median is larger. Make sure you say because if you just state facts like my age is 48 and your age is 18, that's not comparing. I would have to say my age is larger than your age. So here, the average cup size for the 1 cup has a larger median than the 3/4 cup. Center. Shape. they both, the 3/4 cup seems to be some more symmetrical than the 1 cup. The 1 cup seems to be more skewed left because there's more data closer together towards the ends. You don't even have to describe it. You can just say skewed left and you're getting credit. The spread, the 3/4 cup has a smaller variability than the 1 cup, or you could say has a smaller interquartile range than the 1 cup of cereal boxes. Stay in context. Something about cup sugar per content, something about cereal boxes, and you got full credit. Center, shape, spread. Go to B. B, I missed this one when I had to do it in January or, in May, and then I'm an AP grader. I've been an AP grader for about, I don't know, a lot of years, maybe 12 years now. So, when I was, went to the AP reading, I was like, I didn't get full credit for that one. So anyway, I thought the rubric was really hard for B. The first one most kids got, when you have to adjust the new serving size, the mean increases. The median or center increases for the 3/4 cup. So most of the kids get that one. But the second part is what I missed. I said something about the variability, but you actually had to be very specific about it. I said the variability increases as well, but they actually want you to say, hey, the variability increases by 4/3 times bigger. So when you're doing for B, for question B, the standard deviation, when you multiply everything by 4/3, the new standard deviation is 4/3 times the original. So you want to say it's actually 4/3 times bigger. The rubric is pretty strict, I thought, for B. So center increased, the spread, the standard deviation, or it doesn't matter. You can just say spread was 4/3 bigger. And then the very last one, you wanted to focus on the shape. It basically wants to now compare mean. You're comparing means. You want to go, I would start with the 3/4 cup and say that it's fairly symmetrical. So the mean should be close to the median. Where the 1 cup distribution is skewed left. So the mean is going to be left of the median. Hence, the 1 cup will have a smaller median than the 3/4 cup. And that's it. Go to question C and push pause. So hopefully you push pause for 8 minutes and then tried this question. But here, I have had kids, I've given this question so many times through the years, and the majority of them would, like you, may have just literally found the probabilities between each of these values. Found z-score, go to your tables, figure out the area between the two numbers. So you should be able to do that. But that would take a really long time. But not really, you could finish it. But there's another way to think of it other than just guess and check and trying all the options. It did tell you you're normally distributed with a mean of 10 and a standard deviation of 0.2. Here are your 10,000 shellfish. And their, what are we doing? Weights, heights, lengths. And we want to know 40%. 4,000 of them, if it wants the shortest interval, has to come from the middle. Has to come from the middle for the shortest interval. If it's on the sides, then it would have a longer interval. So the shortest one would have to come from the middle. And if 40 out of 4,000, that's your 40%. If this is 40%, what does this have to be? I'm hoping you're like, why didn't I think of that? That's 30%, right? So can I figure out this and this? I'm hoping you're saying, I know how to do this. Okay. Yeah, go get your z-score. Go to your table. Look up 0.30. Do this. I'm going to just go right to my calculator because that's what I have with me. And look up 30%. Let's get up to the right there. 30% to the left. And my z-score is about a half a standard deviation away. And then this z-score is symmetrical, so it's the positive z-score. And now, can I find can I find this value with a mean of this and a standard deviation of this? I hope so. You're a half a standard deviation away, right? Some of you don't even set up a formula. You just are so intuitive. It's awesome. You literally take this times this and then subtract it from 10 or add it to 10, and you're done. A lot of you sort of set up what your z-score is equals something minus 10 over my standard deviation. Sort of use your formula and go ahead and do the math for that and get your intervals, and you're done. Okay, last question. Question D is the easiest out of, oh, this way, sorry, push pause. Question D is the easiest out of all of them. So make sure you save your notes on that, but this is, really, that's the only one that's not an AP question. So, it's really just a straightforward, regular, old-fashioned stat problem. So a little boring, but I want you to be able to do question D. Okay, so number or letter D is as straightforward as you're going to get. In fact, this is not an AP question. It's fairly, direct in terms of what they need from you, but this is great skills that you need, whether you want to use your table or your calculator, depending on how you approach it. But what you want to show the reader is this. You want to show your reader your normal curve and where you're shading. Is it, below? Is it after? And you have to show your z-score. You don't necessarily have to show your calculations, but you have to give the reader the z-score, where you're shading, and that it's a normal curve. Now, if you don't do a picture, you must show the reader something like this notation, capital N, which means you have a normal distribution. I do prefer the picture. Both are acceptable, so put your picture in there, put your z-scores in there, and calculate the area. This z-score, you're looking up the z-score, then you're looking up the other z-score area, and then subtract the areas to get the data in between. There's also a way you can do it in the calculator that I can show you later on if you're interested. This one is just lower bound. They're looking for what percent of the runners are less than 60%. Again, show your z-score, show your area, what direction you want to be looking for. If you don't do your picture, then certainly you could do something like this. What's the probability the z-score is less than that. So you can do a direction through an inequality if you don't shade it. And then the last one is just, the only one that's sort of semi-interesting, I guess, and that is the 45th percentile. The 45th percentile. So if you're given a percentile, you should be automatically going to, hey, I now know under a normal curve how many standard deviations I'm away. When you're given that percentile, I can find my z-score. So you really do. You have to be able to go from here to a z-score. Use your table, find the z-score. Percentiles are, remember, it's the left-hand side we're shading. What percent is less than or equal to that value? We're looking for this question mark. And then you're just going to set up the math. Some of you know intuitively just to multiply it by the standard deviation and then, take that distance from the mean. And there you go. If you have any questions, we'll see each other on Thursday to address them. Thanks.